Clear? Last person. Clear? Say so. Now what is the third one? Push-pull model. So this model has two entities. One is producers. The second one is data consumers. It has only two parties, two users, producers and data consumers. Go to the diagram. So this is nothing but push-pull model. What publisher is doing? The work of publisher is sending messages, sending the information. Where it was sending? In a manner of queue, of frame, in a manner of bits, and this will be published to the queues, and consumer will pull the messages from these queues. Consumers means customers. Consumers means last person. Consumers means customers. Your messages will be published into queue, and messages will be pulled from the queues. Go to the previous slide. Yeah. What publisher will doing? It will publish the messages, push into the queue. Queue means it will act as a decoupler. Means I am sending the data at a certain rate, 9 megabytes per second. Receiver is receiving at a certain rate, maybe 10 megabytes per second. There is a mismatch between the data rate that can be overcome by queue. What queue is doing? It acts as a buffer. It acts as a decoupler. You are a sender. He is sending certain information at a certain different data rate, 9 kilobytes per second, 10 kilobytes per second. But receiver is receiving at 1 megabytes per second. There is a mismatch between the data rate. In order to avoid that mismatch, we will use a queue. Queue acts as a buffer. It will act as a decoupler. So that data rate should match. That speed of the data should match producers and consumers. Understandable? We are publishing the data into a queue in a line. Receiver will pull the data from the queue at a certain data rate. If there is a mismatch, we will use queue as a buffer. We will use queue as a decoupler. Understandable? Go to the next slide. The diagram. Yeah. One of the example is it is nothing but a combination of publish, subscribe, and push pull. The data we stored in the queues gets by scrolling down. We search certain things. Physical design of IoT in Google. We'll get so many content, sensor or subheadings. We'll scroll down. Sensor or scroll down. Then scrolling down internally done by your push-pull communication model. If you search in Google engine, you will get so many responses. You will scroll down till you will get the responses. That scrolling down internally done by push-pull communication model. Clear? What is the example for push-pull communication model? In a Google search engine, scrolling down. That scrolling down is done by feeding the answers, feeding the options, answers. When you scroll down, internally done by push-pull communication model. There you go, Johnny. You got those uniform. There you go, sir. Feeling good. Johnny, my cowl is good. Yeah, the last one is, what is the last one? A model. So this model consists of two parties, client and server. Go to the diagram. It consists of two models, two parties, client and server. Same like the request response only, but it is a bidirectional communication. See the arrow one. We are sending a request, we are receiving a response. Bidirectional communication means they both are dependent on each other. Each request and response are dependent on each other. Same thing, client will request a connection to a server. I want a connection. It was requesting for setting up a connection. What server will do? It will give a response that I have accepted the request. I will repeat it. It is a bidirectional model, full duplex communication model. Both the request and response are dependent on each other. Client will send a request to the server. Client will send a connection to the server. In response, server will say that I have accepted your request. I have accepted the response connection. After that, what client will do? Will send a message from the client to the server. Data frame, data bits will be sent to the server. Upon server, what will do? It will send the messages from server to the client. Bidirectional, full duplex communication. Both are dependent on each other. Once transfer of message is done, client will say, I want to close the request. Connection close request. After closing the connection, server will give a response that connection close response means connection has been closed. I will repeat one more time. Client will send a request of connection to the server. Server in response will send that I have connected with you, or messages that response is accepted from the request. Both are dependent on each other. In the second thing, once the connection is set up, client will send a message to the server. In response, what server is doing? Sending a message from server to the client. Both are dependent on each other. Arrow mark, bidirectional communication. It's not a unidirectional. After doing everything, client is sending, I want to close the request. I want to finish the process. Means connection close request to server. In return, server will say that connection close response. I have done with this. That is nothing but pairing, an exclusive pair model. Both the request and response are bidirectional. Both are dependent on each other. In previous request and response, that is not dependent. Each request is independent. The request and response are dependent on each other. Go to the next previous slide. So that is why exclusive pair is a bidirectional model, including a full duplex communication, which has a full duplex communication. So this connection is constant. It is open. Once the connection is set up, it is constant until unless server closes the request. That is what I have mentioned. Connection is constant and remains open till the client send a request to close the connection. Until unless client send a request, I am requesting, I want to end the process. Until unless then client and server are connected with each other, always connected with each other. Once the client send a request to close it, then only server will close the request, close the session, close the process. Understandable? So one example is WebSocket based communication API. In the further class we will come to know what is that API and all. What is WebSocket communication? Clear? I will revise it. So concentrate here. First one is request response model. Second one is publish subscribe model. The third one is push pull. The name itself suggesting you push pull model. The last one is exclusive pair. Request response. Client will send a request to the server. Server will prepare everything, process the data, process the information, categorize the request, and it will send back to client only. Where it was getting processing, getting the data from a response or from the resources, from the libraries or from the database. That is nothing but request response model. Good example is online search engine. Publish subscribe model. As simple as it is, a publisher is there, A broker is available in the middle. At the end, subscriber. Publisher is producing videos that can be subscribed by the subscriber. Publishers are not aware of subscribers, but broker are managing the topics, sports channel, video channel, any comedy videos that can be managed by the broker. What is the task of broker? Broker will assign a certain topic to a particular consumer only. If subscriber is subscribed for sports channel, he should get only sports related information. This can be managed by the broker. Means producers not aware of subscriber. They don't know who are the subscriber. They just produces. They produces the topics. The third one is push-pull communication. Producers are pushing the data. Consumers are pulling the data from the queue. Queue means in a data frame. 8-bit data, 16-bit data, 32-bit data. What queue is acting? It is acting as a decoupler. It is acting as a buffer. In which case, if the sender is sending the data at certain rate and receiver is receiving the data at a certain different rate, that can be managed, that can be overcome by queue. For example, he is the sender, he is sending the data at 10 megabits per second or 10 megabytes per second. He is the receiver, he is receiving it only 50 kb per second. There is a mismatch. This mismatch can be overcome by a queue, a decoupler, which is acting as a buffer, so that both the data rates will match together, so that both they can transfer and receive the data. That is nothing but push-pull communication model. The good example is online scroll. We'll scroll and we'll get a related information. Last one is exclusive pair, means it's a bi-directional. You have arrow at the right side, you have arrow at the left side. Client will send a request, server will say that I have connected with you. Client will send the messages, server will again send back messages so that I have received the messages. Acknowledgement, bi-directional communication. That connection will be closed only when client will send a message that I want to close the connection, I want to finish the process, I want to end the process. Clear? Understandable? So these are nothing but IoT communication models. So I have given examples, try to understand them, go through them, and if you understand the example, it will become somewhat easier to understand each and every sub topic.